Hey students, so here's a chance for you to look back at our mini assessment from last week. Thursday, go into the Desmos, double check your answers, and if you are going to retake it, you need to reach out and come to office hours to retake that assessment. So here we go, let's walk through this. Oh, I need to pause it. So it's a good idea to have your Desmos open so that you can go back and forth and see what you did. Here, remember this was just an opening question. If we have x to the fourth, y to the third, we're going to expand the top, x times x times x, and expand the denominator in the bottom, y times y times y. So we'll have x times x times x over y times y times y. All right. Expand the numerator, the top, and the denominator, the bottom. All right. So let's go on to number 2. So here we have n squared times n to the third times n to the fourth. Well, if we write these out here, remember this would be n times n squared. N to the third is n times n times n. And n to the fourth would be n times n times n times n. So how many n's do we have all together? Well, count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this equals n to the ninth. This one is our power rule, right? Y to the third to the fifth power. That means I have 5 sets of what's inside. And we learned that if we take a power to a power, we can multiply those powers. 3 times 5. 3 times 5 is 15. Boom. All right, moving on. This one's a little trickier, but of course, you got to show what you know. So I have b to the fifth over c to the ninth, b to the seventh over c to the ninth, or c to the first. So if we have a variable over a variable, with these exponents, we use that quotient rule. So I have b to the 5 minus 7 times c to the 9 minus 1. Well, 5 minus 7 is b to the negative second. C to the ninth minus 1 is c to the eighth. You could have written it this way, or you could rewrite it as the fraction c to the eighth over b to the second. Either is acceptable in this question. Some of you double check. You wrote your places in the wrong side. Some of you put c in the denominator, some of you put b in the numerator. So double check that answer. All right, here, this one's a fun one. We have 9 over 3, m to the fourth, m to the fourth, sloppy, m to the fourth. All right, so if you remember right away, you can say m to the fourth over m to the fourth is 1, right? We could just make that all 1, and we'd be left with 9 over 3. 9 over 3 is 3. If you didn't remember that, you could still say 9 divided by 3 is 3. M to the 4 minus 4 is 3m to the 0. Well, m to the 0 we learned is equal to 1, so that'd be 3 times 1, which would just take us back to 3. Some of you wrote it 3 to the m to the 0 power. I accepted that because it showed me you understood that quotient rule there. All right. Now number 6, all of these equations and periods 4 and 5, you had different variables here, but I'm going to use w to the 12th just to kind of give us this example. And so we have w to the 12th. A couple of ways we could write w to the 12th. W to the 12th is the same as w to the 15th over w to the 3rd, because that would be the subtraction, 15 minus 3. We could use the power rule. How do we multiply to 12? We could say w to the 3rd to the 4th power, because 3 times 4 is 12. Let me move myself out of the way. We could also say w to the 6th times 2. There's a ton of different ways of writing that. And then we could also use the the product rule. We could say w to the 5th times w to the 7th, because those add to w to the 12th. We could say w to the 2nd times w to the 10th, because those add to w to the 12th. The possibilities are literally endless, okay? We could throw negative exponents in there if we wanted. We could throw 0 exponents in there, but those are some simple, straightforward ways of getting to w to the 12th. If you have questions, come to office hours. If you don't have questions and you want to retake the quiz, you still got to come to office hours at 3:30 today, tomorrow, and Wednesday, or this Friday. All right.